Good morning, everyone. In this video, I want to show you how to solve quadratic equation by factoring the sum of two squares. Okay, so again, so when you have two terms that can be that you can write as a square, okay, and the operation between them is plus, we can factor it as a product of two complex conjugates. Okay, so now I have this equation x squared plus 4 equal to 0, and you want to factor by you want to solve by factoring the sum of two square. Why am I saying this is a sum of two square? The first one is already written as a square as well as the 4. Okay, so I can rewrite the 4 as a square, which is going to be 2 squared. Why? So 2 squared is 4 equal to 0. So now I'm going to apply this formula. So when you have a sum of 2 squared, you can now rewrite it as the product of two complex conjugates, which is going to be x plus 2i and then x minus 2i. Okay, so make sure one is plus and one is minus. Then after that, you're going to apply the zero product property. The zero product property, which means that if you have two factors that are equal to 0, one of them is equal to 0. So I'm going to write that x plus 2i equal to 0 or x minus 2i equal to 0. So either one of them must be 0. So for the entire product to be 0. And then you solve for x. Here, to solve for x, you have to subtract. For the first equation, you subtract 2i on both sides. And the second one, you're going to add 2i on both sides. And the new equation is going to be x equal negative 2i. And the second one is going to be x equal 2i. So what are the solutions to these systems, to this a quadratic equation? So I'm going to set the negative number, so negative 2i and positive 2i. As you can tell, both numbers are complex conjugate. Why do I say that they're complex conjugate? They do have the same real part. Here, the real part for both of them is 0, and the imaginary part are opposite of each other. One is a negative imaginary number, the other is a positive imaginary number. So for this example, you have two complex conjugate solutions. So what it means like the graph. So if you're going to graph this quadratic equation, you're going to see that the quadratic equation is going to be above. So this is going to be above the x-axis. Okay. So basically, there's not going to be no x-intercept. Okay. So now let's do number 4. So for number 4, you have x squared plus 25 equals 0. So please pause the video and close the video to solve this quadratic equation. Thank you. Okay, so as you can tell here, okay, so again, you have a sum of two perfect square or 2 squared, while 25 can be written as 5 squared, and x squared is already written as a square. So I can factor it as a product of two complex conjugate. And then I apply the zero product property by taking each factor and set equal to 0 and solving for x. And I found that the two solutions are negative 5, 5i and positive 5i, which are two complex conjugate solutions. Okay, so I'm going to now give you another example, another set. Okay, so now could you please pause the video and solve this quadratic equation, okay, by factoring the sum of two squares. Okay, so as you can tell here, so we wrote for x squared at 2x, everything inside the parentheses and squared. So make sure that you don't write something like this. So this is not correct, okay? Because the x is only term being squared. So if you want the 2 to be squared, you have to include the parentheses like I've done. So always include the parentheses. And then 9 can be written as 3 squares. So the sum of 2 squares is going to be the product of two complex conjugates, a plus bi and a minus bi. And then I applied the zero product property. I took each factor and set it equal to 0 and solve for x. And I end up with negative 3/2 of I and positive 3/2 of I, which are two complex conjugate solutions. Okay, so I hope this video was beneficial to you. okay? Have a wonderful day and thank you for watching my video. Bye-bye.